Problem 2.3.10, solving a linear differential equation. So differential equation is given like this, and then it is a linear. If it is a linear, then we can follow these 5 steps, put it into standard form, find the integrating factor, multiply by integrating factor for both sides, and then put it into very specific form, and then integrating both sides, then solve the equation. Okay, so the first one is standard form. When you say standard form, by looking at the coefficient of dy over dx, which is 1. So the given equation is not 1 because we see x in front of it, so we're going to divide everything by x. So now we have dy over dx plus 2 times 1 over x times y and 3 times 1 over x. Now it is standard form because there's a 1 in coefficient right there, and then this is the p of x, and then this is f of x. Good. Step number 2. We need to find the integrating factor by putting into e to the integral p of x 2 over x dx. Okay, and that equals e, you can take the 2 in front of the integral x dx, and then that is e to ln x, and then for the log, the coefficient can go to the power, so e ln x squared. Now these guys cancel each other, then x squared. That's the integrating factor. Now we need to multiply this integrating factor to this original equation. So if we do dy over dx x squared plus 2 over x times y x squared equals 3 times 1 over x x squared. Now this is a linear equation solving technique. Okay? Up to this point, very straightforward. You can just follow these steps. Now this is the little confusing part. Okay, so when you get to this step 3, the shortcut is just by looking at the first term, okay, and then write it d over dx y times x squared. Okay. And then the right hand side, 3x and x cancel that out, and x. Hey, wait a minute, Dr. Kim. Here's these terms. What happened to this? Now, remember chain rule? So when we have a chain rule, so let's say d over dx a times b, and that is d over dx. So first derivative, okay, and then second one, plus first second derivative that's the chain rule, right? So if we apply this chain rule, okay, to here, let's see what happened. So the first derivative is second one, d over dx y times first derivative, second one, plus the first and second derivative. And this is actually we can do. This is nothing we can do about it because we cannot differentiate y in terms of x. So this is the partial differential equation, and you need to keep that, right? But for the second term, d over dx for x squared, we can do 2x, right? Differentiate x squared in terms of x, which will give us 2x. Now just by looking at this whole result, compare with this guy, they're exactly the same. They're the same. Okay? That's the beauty of using this technique, 5 steps. Okay? So even though it looks like a 2 terms and combine as a 1 term, but by multiplying integrating factor to here, we actually force this left-hand side of the equation into the chain rule form. Okay, so once we get to this, now we have d over dx. I'm going to rewrite the equation one more time. Y times x squared equals 3x. Now we're going to take the step number 5, integrate both sides. Then we have y times x squared. That's cancel out. And then equals, we can take the 3 out, integral of the x. It's going to be just 1 over 2 x squared. We need to put c on the one side, left-hand side or right-hand side. Okay, so that's it. If I ask you to find the explicit solution, then we need to isolate y. So y equals 3 over 2 x squared, 1 over x squared, plus c times 1 over x squared. So we can rewrite this one more time. Y equals 3 over 2x, just 3 over 2 plus 1 over x squared times c. That's it.